very long chapter 4. In 4.10, we are looking at writing quadratic functions in all three of the forms that we studied throughout this chapter. So this lesson can get extremely long and tedious. So in order to keep this video somewhat short, I'm going to do one example from each of the three forms, leaving us with one to do in class together for each. Okay, so for number one, let's just take our first example right away. So in our first example here, we are trying to write the quadratic function in vertex form, which is given to you. So they give you the vertex. Remember, your x value of your vertex is just your h value, and your y value in your vertex is just your k value. Okay, we also need a point on the graph in order to figure out what a equals. So they give us a standard order pair, which would be labeled x and y. So the first thing you want to do is write your quadratic in vertex form by substituting in your h and k. So if I've got y equals a times x minus h squared plus k, let's start by substituting in our h and k. So that gives us y equals a times x minus h, which would be plus 1 squared minus 4. And then we can also substitute in our x and y from the point we're given. So we've got negative 1 equals a times 2 plus 1 squared minus 4. Let's go ahead and solve this for a, because that's really the only variable that we're not given here. So we've got negative 1 equals a. 2 plus 1 is 3. 3 squared is 9. So a times 9 minus 4. So let's add 4 to the other side. So that gives me negative 1 plus 4, which is 3, equals 9a. Just reordering, so I have my coefficient there. Next, I'll divide 9 from both sides. 3 divided by 9 is 1/3, which will equal a. So going back to my vertex form here, remember when you're writing a quadratic in vertex form, you always have your y and x. So really, we are just going to substitute our a value in as well as our h and k value. So we've got y equals a, which we just found out is 1/3, times x minus h, turns into plus 1, plus k, which is negative 4. So this right here is my quadratic in vertex form. Okay, lots of these problems will also want you to write it in standard form. Okay, so in order to do that, sorry, I forgot my squared. All you need to do is go ahead and expand this. So we've got y equals 1/3 times x plus 1 squared minus 4. So let's go ahead and FOIL my middle factor here. So we've got x plus 1 times x plus 1 minus 4. So to FOIL this, got y equals 1/3 times first, so that's x squared, outer, x times 1, which is x, inner, 1 times x, which is x, so that gives me 2x. 1 times 1 gives me 1, minus 4. So then let's go ahead and distribute our 1/3. So that gives me y equals 1/3 x squared plus 2/3 x plus 1/3 minus 4, which we just need to combine like terms, and that will leave us with y equals 1/3 x squared, 2/3 x, minus, and that would simplify to 11/3. So ultimately, that would be my quadratic in standard form as well. All right, we're going to skip number 2 for now. For number 2, all you would need to do is identify your vertex and identify any other point on the graph, and you can go through this same exact process. Okay, so scrolling down to intercept form. Intercept form, honestly, same exact process as we followed with vertex form. Now we're just using an alternative form. So we did our example for vertex form where they gave us the info. Let's do the graphing example for this one. So in order to be able to solve or to write your quadratic in intercept form, we need to know a point on our graph, which we'll just make our point 2 and negative 6. And then you need to know your two x-intercepts, which are given to us. So my x-intercepts can just be, let's see, looks like that's my y-axis. So that would be 1 and 0. And then my second one would be 4 and 0. Those are my two x-intercepts. So from looking at the graph, I have collected all the info that I'm going to need in order to write my intercept form. So similar process to vertex form. Let's start by substituting in our intercepts since those are essential to the writing of intercept form. So we've got y equals a times x minus my first intercept, which would be 1, times x minus my second intercept, which is 4. So next, let's go ahead and substitute in our x value and our y value. So substitute in your x value and your y value from the point that we're given. So my y value is negative 6. A times my x value, which is 2, minus 1. X value, 2 minus 4. And then let's simplify. So we've got negative 6 equals A times 2 minus 1, which is 1. 2 minus 4, which is negative 2. So that gives me negative 6 equals negative 2a, which, I can solve for a fairly easily. Divide both sides by negative 2, and that would give me 3 equals a. So writing this in intercept form, remember we keep our y's and x's. So we've got y equals a, which is 3, times x minus 1 times x minus 4. And that right there is my intercept form. So if I was asked to write this in standard form, okay, all I need to do is go ahead and FOIL my middle section there. So that gives me y equals 3 times x, x squared, x times negative 4, negative 4x, negative 1 times x, negative 1x. So that would combine to be negative 5x plus 4. From here, go ahead and distribute your 3. So that gives me y equals 3x squared, 15x plus 12. And that right there is my standard form for that quadratic. Okay, so give number 3 a try on your own. Just like we just did, same process, different intercepts and points. All right, so the final one we're taking a look at here is on page number 2, and that is writing a quadratic in standard form. Okay, so standard form is definitely the most tedious of the examples because you need to make a system of equation using the 3 points that they give you. Okay, so given these 3 points, let's substitute these values into our standard form. So their first point, our y value is 7. So that gives me 7 equals a times your x value squared plus b times your x value plus c. Then let's go through and do that with all our points. Our second point here, we've got 3 equals a times our x value, which is -2, plus b times your x value, which is -2, plus c. And then our final equation, which is y equals 0 squared plus b times 0 plus c. So essentially, I just substituted in my x's and y's into 3 different standard form equations. From here, let's go ahead and write this as a system of equations. So to write this as a system of equations, I'm going to simplify this mess that I have on the right side. And also, just to keep it uniform, I'm going to move my equal sign to the other side. So right here, I have 2 squared, which gives me 4a plus 2b plus c equals 7. Hopefully you guys are able to see what I did there. -2 squared, so that gives me 4a minus 2b plus c equals +4. Then finally, 0a, 0b plus c equals 1. Okay, so I just simplified and rearranged what I had over there. So luckily for this one, my zeros here in my bottom equation can cancel out pretty easily, giving me right here, c equals 1. So that honestly helps our entire process a ton. Because then what we can do is let's just look at our top 2 equations and substitute 1 in for c, and then let's use elimination to solve for our missing variable. So I've got 4a plus 2b plus c, which is 1, equals +7. And then I've got 4a minus 2b plus 1 equals a +4. So from here, let's go ahead and use elimination to eliminate one of my variables. So right now, both of my b's have opposite signs. So if I go ahead and add these 2 equations together right away, that would give me, first of all, my b's cancel, which is the goal. That gives me 8a plus 2 equals 11. Subtract 2 from both sides. That gives me 8a equals 8, which ultimately gives me a equals 1. So now I've solved for 2 of my variables. So let's just go and substitute this back into, really any of our equations here. So I've got 4 times 1 plus 2b plus c, which is 1, equals 7. Go ahead and simplify. Gives me 2b equals 4 plus 1, 5, minus 7, or 7 minus 5. So that just gives me +2, which will ultimately give me b equals 1. So I have solved for a, b, and c using my systems of equations. So now let's go through and take my standard form from all the way up here and substitute those values in. So that gives me y equals 1x squared plus 1x plus 1, which obviously just simplifies to be y equals x squared plus x plus 1. That right there is my standard form for my quadratic above. All right, so I know this lesson brings in a ton of different aspects from the entire chapter and a little bit from the chapter before as well. Hopefully you were able to hang with me without making this video too long. Please bring any questions you have to class, but we'll make sure to look at each of them individually to make sure that we're good to go. All right, thanks for watching.